Chemistry. Okay, figure 7.1 shows the electrolysis of concentrated and dilute aqueous sodium chloride using graphite. So graphite is a inert electrode. Take note in mind. Take that in mind. Okay, and then gases are produced. Blah blah. Now this is a bit special because there is two beaker, and the two beaker, one of it is concentrated electrolyte, and the other one is dilute. So take that into mind. Okay, describe the differences between what happens when electricity passes through the graphite electrode compared to what happens when electricity passes through dilute aqueous sodium chloride. Okay, I didn't expect this, but not hard, quite easy. In fact, uh, it should be talking about the different charge carriers. Now, in graphite, the charge carriers are actually the electrons, also through the wires. So when it's in the electrode, it's the electron that carries the charge. But once it goes to the electrolyte, it should be the ions that carry the charge. Oh, it's worthwhile to make this difference in your head, in your concept, if you are not aware. So what's the answer? I'm just going to type it out. Mobile. It seems a bit big. Wait, let me adjust the font. Mobile electron. The word mobile is very important because if it's not mobile, it cannot move, it cannot carry charge. It cannot conduct electricity. Graphite acts as act as charge carriers. Uh, Mobile electron. Wow, mobile ions in 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 the dilute AQUEO, aqueous sodium chloride, act as charge carriers. Important here is go straight to the point. Don't be around the bush. If not, your answer will end up very long. I think this is a 2 mark question. Yes, it's a 2 mark question. Oh, it's a 2 mark question. So if you put around the bush, you end up with a very long answer. So this will give me 1 mark. So they want to describe the differences. So most likely is a 2 mark question. They want two differences. So that's one difference. The charge carrier is different. Number two, when the electricity goes through my graphite, all right, the graphite is unchanged. That's why it's inert. But when it goes through the electrolyte, all right, it will actually electrolyze, or maybe we should use the word, we should decompose, all right, to form two different products. So that's the second difference. So first, so typing it out, graphite, sorry, H, graphite electrode remains chemically unchanged while water, sorry, is that water? Oh, water get, what passes through? Oh, while the water in aqueous dilute sodium chloride solutions gets decomposed into hydrogen and oxygen. Okay, straight to the point. Identify the gases collected in test tube Y and Z. Y and Z. So these two, this is dilute aqueous sodium chloride solution. Okay, your test tube Y, this is the positive side. So this is the positive electrode. Otherwise, this is also known as the anode. Anode should give you oxygen. You should know. So this should be oxygen. It's dilute. Yeah. What happened? Why I cannot write? blue. This should be oxygen. And then the other one should be hydrogen. The ratio of the volume collected is observed to be 1:2, Y and to Z. Yeah, H2O, so makes sense. Explain this observation. You may include half equation. So when every time the question say you should include or you can include, actually they are hinting to you to include it. So do not regard it as just an advice or a suggestion. It's definitely not a suggestion. It's telling you please do it. So I'm going to write both of the half equation. Let me see how many marks this is. I think when I cut it, it got off. This should be a 4-mark question. So yeah, it's not as simple. It's a 4-mark, then you know that you need to include a lot of things. So let's write the both half equation. So at the anode, you have your hydroxide that's being discharged. Right. If you have memorized, you can just write in the numbers directly. If you did not, then you can just write in all the products and the reactant. Then you go and balance it. End of the day, you still have to check that everything is correct. O2. Okay, the skill is more important than the memorization. I don't really advise to memorize. So cathode, your H plus, okay, aqueous, and you take electrons, and it become H2 gas. Okay, so this one I want to type, I want to write. Okay, copy. Okay, number of moles of electron loss at anode is the same as the number of moles of electron gain at cathode. Therefore, you can write times 2 in the cathode and balance it so that it's 4:4. Then you realize that you have the same, or you can just describe it. Therefore, 2 moles of H2. Yeah, I need to write subscript. What's my subscript? Okay. 2 mole of H2 is produced with 1 mole of O2. Okay, stop. Okay, and the question was what? What was the question? The question was on volume. So you must also talk about volume. If I stop here, I might lose 1 mark because I didn't relate it back to volume. So it's very important here. We don't just talk about mole. Here we already justify the mole. We need to justify back the volume. Okay, so molar volume of all gases at RTP is the same. It's the same. Therefore, the volume ratio of hydrogen to oxygen gas is also 2:1. Okay, that's it. Next, identify the gases collected in test tube W and X. Okay, W and X is these two. Now, this is concentrated. So, the only difference would be your anode. So, instead of oxygen coming out, you're going to get chlorine, which is Cl2. So, better to write the full name. You can write both also. You can chlorine gas. Or just write Cl2 if you want. And the other one will still be hydrogen gas, H2. State the ratio. Ratio should be 1:1. If you're not sure, you can write the half equation out to see for yourself, and then you try to balance the electron. A universal indicator is added to the solution in beaker 1 and 2 after the electrolysis. Predict the universal indicator in beaker 1 and 2. Okay, beaker 1, let's take a look. Beaker 1, we are going to have a lot of chlorine coming out. No, we are beaker 1, there is no OH minus being discharged, but we have a lot of H plus being discharged. So what is going to happen? There's going to be an imbalance of H plus, OH minus compared to H plus. So that would make it more alkaline. Initially, it is neutral, but because there's an imbalance, as more H plus is being discharged, it will be imbalanced. So it's going to be violet. Of course, I think some student might write purple. I think we can accept that. Or blue. Okay, but fine. I think blue is fine. Blue is fine. Okay, because it means slightly alkaline, so it's possible. Color in beaker 2. Beaker 2, we have an equal balance loss of H2 and no OH minus and H plus being discharged. So it should still remain neutral. So what's the color for neutral? It will be green. Okay, then you explain what I've just said. Okay, I need another box here. Paste. In beaker 1, there's a full stop. In beaker 1, H plus and Cl minus. Oh, the Cl cannot write like that. Cl minus ions are selectively discharged. There is thus an imbalance of OH minus. Actually, instead of imbalance is a word I prefer, but in this case, if I just write like that, it's a bit strange. There should be an overflow abundance. There will be an abundance. There is thus there is thus more. Let's just keep it simple There's just more OH minus ion left in the solution compared to H plus. This increases the pH of the solution. Okay, make all this subscript. Oh no, it's not subscript, superscript. Beaker 2. H plus and OH minus ions are selectively discharged. There is no change in the balance of H plus and OH minus ions in the solution. Thus, the pH of the solution remains unchanged. Thus, the solution remains neutral. Okay, again superscript. Okay, next question. This is called a down cell. It's a commercial electrochemical cell used to obtain sodium metal by the electrolysis of molten sodium chloride. That means there's only sodium chloride, there's no water. Okay, chlorine gas coming out from there, you get molten sodium on top. Oh, it floats on top of water, so this is okay. Inert cathode, okay, fine. Yep, and we have an iron screen. Iron screen is to prevent the sodium from going over to the other side. Okay, fine. Why is the screen needed? I was talking about the screen and immediately they asked me about the screen. This is to prevent the it's molten, so it's very hot. So it's to prevent the hot reactive. No, you know, I mentioned that it's also reactive. Hot reactive sodium. Obviously, we don't want them to come into contact. Sodium from coming into contact with the chlorine gas as you react back into sodium chloride. Yeah, and reacting back into sodium chloride. That's the only answer, lah, frankly. Anything else, at this level, we wouldn't know. So this is just infer the answers, okay? A student claimed that the product cannot be, will be the same even if a concentrated aqueous solution of sodium chloride used. That's not true. So no matter how concentrated it is, sodium will never come out. So that's not true. Okay, so that's basically a summary of what I'm going to write. Or you should have thought about that. Okay, do you agree? No, I don't agree. Yeah, I have to say no. I think that's one of the marks. 2 marks question. No, big no. Okay, no. Hydrogen gas will be produced instead of sodium metal at the cathode. It will be the same even if a concentrated aqueous solution of sodium chloride is used. Product will be the same. No, hydrogen. Hey, why my hydrogen become like that? The other product at the anode remains the same. Which is chlorine gas. I think it's fair enough. I think 2 marks. Maybe 1 mark is no. Yeah, that's it. Okay, explain with the 8 1/2 equation. Why chlorine gas cannot be obtained if the graphite anode is replaced by a copper anode? You'll become a reactive electrode. Or in this case, we have to use. Hey, why I cannot get my thing out? Okay, that's my box. Oh, they want half equation. Okay, so I have to write half equation. No lah, write half equation first. Okay, let's write half equation first. For copper, what's going to happen if it's copper, especially at the anode? Copper is going to be like this. Copper 2 plus, copper is going to become this. It's going to throw out its electron. It's going to lose its electron. Copper will loses electrons more readily than chloride ions. Hence, it will be preferentially discharged instead of chlorine. As to form okay, as a reactive electrode, right? You'll always behave. You'll always be more preferentially discharged. Okay. Next, student uses moist litmus paper to test for chlorine gas. Upon seeing that the moist blue litmus paper turned red, he concluded chlorine gas must be present. Do you agree with him? Not necessary. Just show that it's acidic because there's a lot of acidic gases. Now, if you have memorized or go and learn what is your chlorine test, it has to bleach the paper. It has to bleach the paper. Okay. No, I don't agree. The litmus. Okay, just reiterate again what is the what do you observe? The litmus paper must turn red and then bleach to confirm presence of chlorine. Some chlorine gas will bubble into a sodium iodide solution. Describe what will be observed after some time. Chlorine was bubbled into sodium iodide. The sodium iodide will turn brown, right? Because the chlorine will displace the iodine. Color solution turns brown. Explain why a reaction occur. Okay, chlorine is more reactive than iodine and displaces iodine from Ki. I don't write the whole name out, so I write Ki. Exam, please write the whole name out. Okay, from Ki. Next. Oh, new question. Okay, let's read first. Electrode P and Q are made of graphite. That's inert, so we have no issue of reactive electrode. Oh, but we have copper and zinc. That seems like a battery. That's a simple cell. So not so hard. It's simply using a simple cell instead of your normal battery. So just write it down. Zinc being the more reactive metal, you will tend to lose. You will have a net loss of electron. So it's going to be zinc becoming zinc 2 plus 2e. This is your more reactive electrode. And then copper will be forced to take electron. So copper 2 plus 2e give you copper. Okay, what do you want? Hence, describe the expected observation in cell 1. I will see the copper electrode becoming thicker and the zinc electrode becoming thinner. Okay, 2 marks. I think I need 2 lah. Okay, zinc. Ignore this. Zinc electrode become thinner. While copper electrode becomes thicker. I don't know whether they count this as 1 mark or 2 marks for what I've written. It could be zinc 1 mark, copper 1 mark. But being the Kiasu Singaporean, we want to be safe. We'll talk about the solution also. Because the copper is not being replaced. The copper is coming out. So gradually your copper 2 sulfate is going to become zinc 2 sulfate. It's going to become zinc sulfate solution. So your copper is going to lose the color. So from blue, it's going to become lighter and lighter. So the solution changes from blue. Wow. Oh, very blue when I wrote this. Become blue to colorless gradually. Okay, next question. The voltage of cell 1 was found to be 1.10 volt. Suggest the voltage if the copper electrode in cell 1 was replaced with silver. Explain your reasoning. Now, the value do we have or 1.1. We was given 1.1. So it will be higher than 1.1 because the gap should be bigger. Or it should be a bigger value. So it's a bit hard to guess here what the actual value is. Just guess a slightly higher value lah. Or any value. So maybe 1.2, 1.3. Just going to go with 1.3 or maybe 1.2. Okay, so just the voltage if it's replaced. Okay, the voltage should, I'm going to write. Uh, anyway, it's just an estimation. Don't need to be so, yeah. It could be, it should be 1.2 volt. Reason, the difference in reactivity between the zinc and silver. Oh, so slow, yeah. Is greater than the difference between zinc and copper. Okay, I'm sorry for the handwriting because the pen is not, it's not reacting, and when I try to write fast I cannot see what I'm writing, so you'll come out very bad. If I write slowly I'm going to lose my mind because wow, it's just too slow. Okay, after a few minutes, I'm trying to type if it's going to be long. Okay, I will try to type if it's long. After a few minutes, 16 cm cube of gas was collected. Electrode P in cell 2. Electrode P is the negative electrode, while electrode Q is the positive electrode. What volume would you expect at electrode Q? Include half equation. Okay, this one is a 3-mark question because it was not clear. Electrode P, let me see. I just want to make sure. Now, it's quite nice. They actually tell you that it's the positive and negative, but let's just say they never say. Zinc actually gives out electrons. So electron will flow in this way. Okay, so P will receive electron from zinc. Well, go through one whole round of all this liquid, and then Q will transfer the electrons back to the copper. So electrode P is where you receive electron. So the cation will go to P. So P is the cathode, which is right. P is the negative electrode because it's the cathode. So this is something that you should be able to find out yourself, even if they never say so. So P being the cathode, P would get what is this? Dilute hydrochloric acid. So P being the cathode would give you hydrogen gas and is dilute. So Q being the anode will give you oxygen. So we'll just write the half equation, which is something you are very familiar with. So half equation I still write lah. So at P, okay, again your half equation you should be very familiar with. And then Q, your hydroxide being discharged. Okay, this should give you 1 mark or 2 marks, I don't know. Because its total is only 3 marks. Okay, fine. Then we need to calculate what volume of gas would you expect at electrode Q. Maybe it would be helpful if I actually combine the two equations. Yes, I should. So from here, I'm going to combine the equation because action speaks louder than a lot of phrases and a lot of statements. So here is 2 electron, here is 4 electrons, so times 2 So final, I'm just going to write here overall is 4OH minus plus 2H plus. Okay, and it will give you 2H2 plus O2. And then the rest you cancel away. So you're left like that. Then you plus 2H2O. So you can see that the ratio is 2 is to 1. Mole ratio of H2 is to O2 is 2 is to 1. Okay. Wow, that's a lot of questions. B10. Brush electroplating is used to electroplate zinc onto very large iron support to be used in building. Metal brush spreads a layer of aqueous zinc sulfate over the iron surface. A battery gives the brush a positive charge and gives the iron support a negative charge. Oh, that's a positive. The brush is positive. That one is negative. A thin coating of zinc then form on the surface of the iron support. Isn't this like plating? Yeah. Okay, two different type of metal brush are available. One type of brush is made from zinc. The other type is made from platinum. Platinum brush are more expensive. However, zinc brushes need replacing regularly, of course, because the zinc will get thinner and thinner. Okay, I hope you can see that. Huh? Okay, this one I'm not going to type. I'm going to take my text box. Okay, when zinc brushes are used, the zinc electrode is oxidized to form zinc ions, which you know for light plating, okay, resulting in the zinc brushes wearing out. Now I might want to put a hyphen. Oh, because this wearing out and our common sense of wearing our normal sense of wearing out is a bit different. That's due to friction, but this is obviously due to electrolysis. Okay, and require regular replacement. However, platinum is inert. Use the word inert. Is inert electrode and thus will not react and can last much longer. Okay. During the process, a worker needs to hold the brush. Polyethylene is usually used as the material for the handle of the brush. Why is a suitable material? Okay, this is talking about why is an insulator. So again, just jump in, but of course you must also state what is the structure of polyethylene. If you're not sure, you go back to your organic chem macromolecule. You know, don't say it's a simple molecule, then that's gone. Then you're gone already. Even though there is a reason for other material why they cannot conduct electricity, you cannot say that of polyethylene. is not a simple molecule. Polyethylene is a macromolecule. Polyethylene is a macromolecule. It consists of macromolecules, which here please do not jump into okay is covalent bond and then a lot of or very strong contact, all that. Please, those are not necessary here. Yes, it is part of the structure. Do not include all that. Is you're just making it super long and then you get distracted. All right, jump straight to the point. Just one word is made consists of macromolecule, which of which there is a absence of mobile electron, of which there is no mobile electron, or mobile charge carrier. Oh, okay, of which there is no mobile charge carrier. Charge carrier is better because it includes ions. No mobile charge carriers available. Hence, it cannot conduct electricity. Hence, it cannot conduct electricity. And thus, link back to the question, it is suitable to be the handle. Okay, next. The monomer of polyethylene is said to be unsaturated and is able to undergo addition reaction with hydrogen gas in the presence of nickel catalyst at 200 degrees. Outline a simple test including the expected observation to distinguish the monomer of polyethylene and the product formed from the addition reaction of the monomer with hydrogen gas. Okay, that's quite simple actually. It's just that they go beat one round bush so that it's not so clear cut to you. It's obviously trying to differentiate between ethene and ethane. But as a 3 mark question, yeah, you need to mention ethene and ethane. Okay. Ethene is the monomer and ethane is the product after hydrogenation. Hydrogenation. Okay, then you describe the test. Bubble both gases to two separate test tubes respectively. To two test tube containing test tubes containing aqueous bromine separately. Ethene will decolorize the content of the solution while ethane will not make any effect. Explain why the iron support coated with zinc does not rust, even if the zinc coating is scratched. Huh? Iron supported or coated with zinc, or because the zinc coating will help to sacrificial protection. Okay, I want my text box. The layer of zinc protects. Maybe you should say isolate lah, or buffer, prevent, shield, prevent the ion support from coming into contact with oxygen and water. Even if the layer is stretched and exposes the iron will not rust, as zinc is more reactive than iron and will oxidize in place of iron. Try not to use the zinc or rust, because rusting is a layman term that actually we use to describe for the oxidation of iron. So if it's zinc, by right, rusting is not accurate. So use the word oxidizing or corrosion instead. Okay, that's it. D, electrolysis is said to be a non-spontaneous and endothermic reaction, which require external voltage to drive such reaction. Explain why brush electroplating is considered as an endothermic. Which require external voltage to drive such reaction. True, endo we are using a battery to do it. Explain why brush electroplating is considered an endothermic reaction. Okay. This is not an easy question for student, because usually we don't test the concept in such a manner, especially in terms of energy. But I think it's quite understandable if you talk about energy in terms of the battery providing energy. That part I think most students can get it. I think okay. Energy is taken in at the anode because let me see. Where's the battery? Battery is here. Yeah, because the electron will flow and then you'll come to here. So again, you cannot use the conventional current. You must use whatever we know now. Electron actually flows. So come from this side, electrons go to the battery. Okay lah. Energy is provided by the battery. Is it a battery or is it it's a battery, right? Yeah, it's a battery. It's a battery. It's provided by the battery, and to What is happening at the zinc is oxidized? Eh, okay, fine, fine. I think I know. We want to oxidize at the anode. Energy is provided by the battery to the anode for oxidation to take place. If you do not know oxidation, it means your metal becoming ions. That's why oxidation takes place. So basically, what you are doing is you are kicking out the electron, and you require energy to do that. Or you're kicking out the electrons. So you're breaking the bond. You're overcoming the energy that is holding the electrons in place. So you need energy to do that. So we want oxidation to take place. We provide energy. Okay, sorry, provided. Okay, for oxidation to take place, so that electrons can be gained at the cathode. Correct? You lose electron at the anode, you gain electron at the cathode. At the cathode for reduction to take place. Good enough lah. It's a 1 mark question. But I think most students cannot do this because it's not something that we really teach. Right? They say positively charged, negatively charged. And then yeah. Good enough lah, because it's just the two metals. Okay, question 10. Apparatus used in electrolysis of concentrated aqueous hydrochloric acid. Write the half equation with state symbol for reaction electrode. Again, you know, we just keep repeating. But this is concentrated. So at the X, what is X? X is your cathode. So it's your H plus. Okay. So 2H plus 2E give you your H2. You want to be safe, you write in the state symbol as well. Carbon, because it's concentration, so chlorine is going to be coming out. Okay, half equation done. The gas discharge at Y is bubbled into a beaker containing aqueous potassium iodide. So chlorine goes into potassium iodide. What are you going to see? You're going to see the potassium colorless solution becoming brown. Yeah. With the aid of a chemical equation. 3 marks question. Okay, so equation, write the equation first. Cl2 plus 2I minus. Why am I writing? Wait, they want chemical equation, not ionic. Shit, let me erase. Cl2 plus Ki. Okay, and then it becomes KCl plus I2. Balance the equation. Okay, we're done. If you write state symbol, you go here. I don't think there's a need to. What will you observe? Okay, explain. Describe and explain. So let's explain. Let's describe what we see first. We see colorless solution being or turning brown, which is your iodine. Okay, and the reason is chlorine is more reactive. See, this is a keyword. We keep using the same keyword, okay, than iodine. Chlorine, again, keyword coming. Chlorine displaces iodine from where? From Ki. Okay, or your potassium iodide. Please write the full name if you can. My hand is getting very tired from this electronic pen. Okay, after the electrolysis was allowed to proceed, it was observed that a new product was formed at carbon electrode Y, state identity. Allowed to proceed for some time. That means it become dilute already. Y was initially giving out bubble, chlorine. So after some time, it actually become dilute. So that's why now is oxygen. I'm not going to type, I'm just going to write because it's easier. Oxygen gas. And explain why it's formed. Over time, concentration of chloride ion will decrease. Cl minus will decrease. Why? Because they get discharged. Don't need. I mean, you can say I don't want to say. I mean, it's good enough to say already. Concentration of Cl minus will decrease, and therefore the concentration will play a part in who gets discharged, and therefore OH minus ions become preferentially discharged. To form O2. Another experiment was carried out to electrolyze copper 2 sulfate solution using copper electrode, and this is copper plating. Student A commented the color density will remain unchanged. Yes, that's true because the copper 2 sulfate, yeah, will be taken from the copper. Okay, student A is correct. This is very standard of the meal. At least this kind of question you should be able to do. Those harder one maybe give and take a bit. See, depends on the situation. But this kind of very simple, straightforward question you should be able to do. Okay. Just describe what happened at anode, what happened at cathode, given the half equation. I think that should be good enough for 3 marks. At anode, copper becomes ions. Copper dissolve lah. I really click it. Copper dissolve to ions. So copper bracket S become copper 2 plus. Then at the cathode, copper ions are discharged and copper is deposited on the cathode. Then again, you write your half equation. Copper. Okay, solid. Give you copper solid. Therefore, concentration of copper 2 ions remains unchanged. And blue. Finish. Last question, I think. Yeah, don't know lah. Okay, let's do it. Let's do it. A student, electrolyze aqueous copper 2 sulfate using two setups shown below. The electrode used in each setup are made of the same material. However, the electrode used in setup A and B are made of different materials. Name the particles which transfer charges through the copper wire. Oh, this is so simple. This is something very basic that I think I repeated so many times. So what are the particles that through the wires? Electrons. What is it through the solution? Is going to be ions. Okay, don't need to specify which ion is the ions. Okay, straight which electrode is the setup? This one I think you should know. So setup A is your A1 is the cathode. Setup B is your B1. Okay, just look at observe who increase, decrease, all this. Okay, C. Explain with an appropriate equation the increase in mass at electrode at A1 and B1. Okay, I'm sorry, maybe I should have explained. Which electrode is the cathode? Now, if you see, the electrode used are made of different material. Who gets thicker? Mass of electrode A increase. Mass of electrode B increase. The electrode that become thicker means the copper cation is being discharged there, and that's why it become discharged to become copper and it get deposited on the electrode. That's why you become thicker. So the one that get thicker is always the cathode. So that's it. So that's why it's A1 and B1. Since A1 and B1 is the one that increase. Okay, explain with an appropriate equation the increase in mass at electrode A1 and B1. Explain the increase. Okay, basically that's what I just said. All right, so copper 2 ions gain electrons and thus become copper. So you just write the equation Cu2 plus write the half equation of the reaction taking place at electrode A2 and B2. So the other side is the one that either give the give the copper or it's not, but I need to take a look. Sorry, this one I see too fast. Okay, let's see. Electrode B2. B2 A2 remain the same, but B2 decrease. So B2 must also be copper. A2 remains the same. Oh, they are made of different material. A2 remains the same. That means A2 is not a reactive electrode, it's inert. But B2 should be copper. Yeah, B2 should be copper. So in that case, Half equation at A2 is your normal inert electrode. That means hydroxides will come out. That means it's oxygen. So your normal hydroxide discharge equation. B2 copper, same thing. Now no, not same thing. Copper, then you have copper's ions. Describe how the electrolyte of set A would change by end of experiment in terms of its pH and Y. Okay, how the electrolyte would change. Of A. A is the one that has inert electrode. So I would say that Cu2 plus and H plus are, I don't like also, but I have to write very long word, preferentially discharged or selectively discharged, leaving behind H plus. Uh, Thus, there will be more. Sorry, OH minus. Why did I write H plus? It's a minus. Sorry, very hard to erase. OH minus, there will be more H plus ions. Its pH will decrease. Finish. Suggest the material that are used to make the electrode in set A, carbon, graphite. Okay, can be carbon or graphite or platinum. Anything that is inert that you know of is okay. Set B should be just copper because it